This is the last video for section 5.2, and in this video I'm going to talking about a little bit more advanced example. For this example, we're going to use two different methods still. So the example we have is example 5. We have a secant of x plus tangent of x all over sine of x equal to cosecant of x over secant of x minus tangent of x. So from the past 4 examples, I mentioned that we prefer to work from more complex side, but it doesn't really necessary. We can work from either side, either the left hand side, or we can start from the right hand side. There are problems if you start from left hand side, it will be easier than start from the right hand side. There are problems, there's not really that much difficulties like this, this problems. So I'm going to show you two different methods. This first method, I'm going to first start from the left hand side, and then I try to work my way to the right hand side. However, because I already finished the problem, so I have a little bit kind of TT, so I know what is going to happen here. However, I cannot really directly get from left hand side directly to the right hand side, so I'm going to go to a midpoint, and then I'm going to work from the right hand side to matching to the midpoint. So this is the first method. Okay, so I'm going to start from left hand side. I have secant of x plus tangent of x over sine of x. So secant of x I can rewrite as 1 over cosine of x, tangent of x, sine of x equal over cosine of x, or over sine of x. On the numerator, it will become to 1 plus sine of x, all over cosine of x, all over sine of x, where the mean division is divided by sine of x. So I'm going to do a little bit intermediate step. Which becomes to multiply by 1 over sine of x. So to the left hand side, I actually end up with 1 plus sine of x, all over cosine of x times sine of x. I cannot really continue to do anything to change it to something like a cosecant, secant, and tangent. So I pretty much quote unquote give up to the left hand side. So I'm going to working on the right hand side. So on the right hand side, I'm still doing the same thing. Cosecant is 1 over sine of x, secant 1 over cosine of x, tangent sine of x over cosine of x. Combining them, so I end up with cosine of x all over sine of x times 1 minus sine of x. I didn't really go or having the same term to the end of both my left hand side and the right hand side. So I have to changing them. Comparing to the last line of the right hand side and the left hand side, on the denominator I have the sine of x, that's good. I do have one m sine of x in the form, one is 1 plus, another one is 1 minus. I do have the cosine of x, but it's the wrong, but it is on the different place. So what I'm going to do is I'm going to divide by cosine of x on both numerator and denominator. When I'm going to multiply. After I'm multiplying them, I will end up with cosine squared theta, or x, all over cosine of x times sine of x, which what I want, but a little bit extra, 1 minus sine of x. So here I'm going to using the identity, which I'm going to rewrite the cosine squared x in terms of 1 minus sine squared x. And then I'm going to factor the 1 minus sine square become to 1 plus sine square and 1 minus sine, or 1 plus sine of x times 1 minus sine of x. Which will equals to 1 plus sine of x over cosine of x times sine of x. Now they are matching. Hence, left-hand side equal to the right-hand side. I verify the identity. So even though from this method, you can see I personally really like to write everything in terms of sine and cosine. For me, that is the most easy way. I do not really, or I can simplify everything to the simplest form. I do not really require, or it doesn't require me to remember a lot of identities. I do not need to use a lot of identities. But yes, it's a little bit longer, a little bit tedious. It requires a lot of algebra. But if you feel like you do not want to, or you don't mind having to remember some of the identities, then you can consider the second method. So the method 2, this time, instead of working from the left-hand side, I'm going to start from the right-hand side. And then this time, I'm going to work directly from the right-hand side to the left-hand side, no midpoint. And this one requires something other than sine and cosine. Sorry, my bad. I'm going to still start from the left-hand side. Okay, so on the second method, I'm going to start from the right-hand side and then work all the way to the left-hand side. So my right-hand side, I have cosecant x over secant x minus tangent of x. So right-hand side, well, equals to. So for this method, I do not want to use any of the sine and cosine. So I'm not going to rewrite cosecant, secant, and tangent in terms of sine and cosine. But the strategy I'm going to using is both sides containing secant, tangent. So I do want it. But the only difference is on the left-hand side, I have the plus, but the right-hand side, I have a minus. So I want to create some similarities. So since I do not have secant x plus tangent x, I'm going to create it by multiplying both numerator and the denominator by secant of x plus tangent of x. When I'm multiplying them, on the denominator, I'm going to end up with secant square x minus tangent square x. On the numerator, I just have cosecant of x multiplied by secant of x plus tangent of x. I'm not going to multiply the numerator distributing them because I need exactly secant x plus tangent of x. So I'm not going to break in the form. Okay, so once I have this one, I'm going to try to simplify it, but as I mentioned, I'm not going to changing everything in terms of sine and cosine, but how can I simplifying it? Now we're going to using our identities. So we have secant square and tangent square. From the identity, we have secant square exactly equal to tangent square plus 1. So that's the identity we're going to use. So I'm going to replace secant square by tangent square plus 1. And then the denominator will be simplified to 1. We do temporarily want to keep the 1 for right now, because we do want to remind us we have a fraction. Okay, so the only thing we still missing is the sine of x, but we have the cosecant of x, which is 1 over sine of x. So to have a middle step, cosecant of x is 1 over sine of x. So once we multiply them, we end up to the right hand side.